Good afternoon, everyone. The video from yesterday is up and running, so you should be able to see it. And we're working still on our section, which is basically to do with data and types of variables. So to give you a quick summary of what we were doing last time, data, the information that you collect, right? Variables is another term for it, is essentially broken into two main categories. Categorical is basically data that's not numbers, you know, things like your favorite color, what country you've been to, your child's names, and that splits into two different groups. One is called ordinal and the other is not ordinal. So ordinal would be situations where that data could be put in some kind of order. So it could be, for instance, you know, senior, junior, sophomore, you know, that kind of thing. Yeah, the variables are, I'm a sophomore, I'm a junior, but couldn't you naturally put them into an order? Maybe the variable, the data would be the grade that you got, a letter grade, like I got an A, I got a B, I got a C, and that is quite natural. So if you can put it into some kind of reasonable order, except for alphabetical, we don't use alphabetical because everything could be put alphabetical, I guess, if it's ordered. You put it into the ordinal company. Now, if there's no particular reasonable order, you just put it in the group called not ordinal. So an example of not ordinal might be people's names. Right, forget about alphabetical, right? Just people's names. That would be not ordinal. Countries you've been to, that wouldn't have any great structure to it either. And then the other kind of numbers are actually the more useful ones, the ones we can do more with. Is quantitative numbers. These are numbers. The data is physically numbers. And there's two kinds. There's continuous and not continuous. Continuous is numbers where not only can you get two consecutive numbers, but you can actually get all the numbers between them. So not only can you get 5 and 6, but you can also get anything between 5 and 6, like 5.1234 if you wanted to, or 5 3/4. So continuous would be things like your height or your weight. And not continuous, well, these are also numbers, but you can only get fixed values. You can only get 5 or 6 or 7, that kind of thing. But you can't get everything between two consecutive numbers. So if it's 5 children or 6 children, that's it. It wouldn't make sense to say you had 5.1 child, right? And that's kind of where we were last time. And we're going to do some more questions on that. In fact, let's just focus on doing some homework questions on that, and then we'll look at the second part that deals with, we'll just show you what it is, pairs of data, explanatory and response. So we'll be looking at that later, and that's not the one I want. So let me try that again. It's there.
Nice.
Hi, someone got a question.
No, I said nice whiteboard, by the way.
Oh, this? Yeah. Well, it's got lines, and I call it a whiteboard because I can't think of a better name for it. Probably I should just call it paper. But it's the closest I've got to a whiteboard, so that's why I call it that. And now, before I forget, because this just came into my brain, if you've watched any of my videos, do you want to tell me if something's not right about it? So if the quality is not up to it, I can re-record it or save it, whatever the word is, in a higher resolution. But the problem with doing that is it takes the software I've got about an hour to render a video. And so if I double up the quality, it takes it 2 hours to render it. And I have to render it in such a way that I can then, it works on YouTube. But I mean, if it's just not usable, I need to know that. Right, are we looking at types of variable chapter 2 now? Have I got it on the right screen? Thumbs up, great, okay. So what we're looking at here is it categorical or is it quantitative, right? So I think we've already done examples of that. Let's look at this one. For each of the following quantitative variables, explain whether it is continuous or not continuous. Okay, so if you took someone's body weight, I would say it was continuous, right? So it's either that dot or that dot. And the way they do it is, since every value within some interval is a possible response. That's just the way they said what I said earlier, right? If you get 5 and 6, you can get everybody in between. Now, that one up there is actually, if you read it carefully, it's got an extra word that makes a lot of difference. Not every value. That's actually the complete opposite of what continuous means, right? So be careful, because sometimes you say, oh yeah, it's continuous, but you don't read it and you click the first continuous because that's the word you saw. In this case, you better pick that one. What about the number of text messages? We may have done this one before, but it's good to overlap if we have. Continuous or not continuous? And the first, second, third, or fourth dot would be the easiest way to answer that for me. So 1, 2, 3, 4. What do you think? Text, the number of text messages that you send in a day. I can't see any fingers. 3. 3 is good. Let's see. Not continuous, since not every value is possible, right? And number of codes and so on. That's something we haven't covered yet. Okay, do I want to do this one? Yeah, let's do one of them. For each of the following, indicate whether it's ordinal or not. If the variable is not ordinal, then indicate what it is. Okay, so we could have phrased that clearer, but never mind. Patient rating of pain felt on a day after a surgical procedure, and it's on a 7-point scale, where 1 is, I can't feel any pain. Can you imagine? 2, 3, 4, 5, and 7, please let me die, I guess, extreme pain. Right? So that is what kind of data? Be careful here. It's almost like a trick question. Is it ordinal?
I want to say it's ordinal. It's not ordinal. But,
oh, yeah. Stick with your first thought. It is ordinal. But you might say, but it's got numbers.
right.
Well, aren't you allowed to have numbers as codes? Because isn't the code 1 just for the word none? They could have just said none, couldn't they? But they're saying 1. It's easy to control. And isn't it in order? So that's what makes it ordinal. Right? If you ever been stopped in the mall or someplace and a guy comes up with you and says to you something like, what's your opinion of this politician? And they give you a scale from 1, I like him, down to 5, I hate him, or reverse of that, 5, I hate him, 3, I don't care one way or the other, and 1, I like him a lot, that kind of scale. That's very common in polls. It's easier for someone to write down, he said a 3, than for them to, he said, the whole word. And it's easier on computers as well, because all you do is you code the data and say, this answer is a 2 and that answer is a 3. So it does count as an order. We haven't talked about them, so I'll just skip by them right now. Right, that's probably enough of those. I'm going to pick a couple just to kind of finish this off, and then we'll be looking at explanatory and response variables. So here's my 2 guys. All right, my first story is you collected data, and this data is the number of siblings that they have. And my second set of data is the maximum temperature recorded in 1 year in, say, Bremerton. Okay, let's look at number of siblings. What kind of data is number of siblings?
Quantitative.
Correct. Is it continuous or not continuous?
Discrete.
Right, which is not continuous. You're right, discrete's a better word, but the book uses not continuous. What about the maximum temperature in a year in Bremerton? Right, the hottest it got this year, whatever. Quantitative or categorical?
quantitative,
Correct. Continuous or not continuous?
continuous.
Yeah, because can't you get 91 or 92 or 91.1234, right? Anything in between can happen. Someone give me a ordinal categorical data. Give me an example of something that's categorical and ordinal. They're always the hardest ones to think of.
The month you were born?
That'll do. Would you agree January, February, March is a kind of natural order to it? This should be easy. Yeah. Categorical data that is not ordinal.
Hair color.
Why not? That works for me. Yeah. So I hope by now we're pretty comfortable with the terms and what kind of data fits into which category. And we are aware that there's some grey ones that we try to avoid because they're just a matter of opinion. So hopefully the book keeps, the homework keeps away from the grey ones, and it's pretty clear in each situation which of the categories that they fall within. So now we're going to look at explanatory variable and response variable. Most data is collected in this format. It's actually a pair of data. You normally ask someone a question and then it's the answer that you're recording, right? So I say, what's your age? And you say 27. The explanatory variable, right, was, if you like, what did you ask them, right? Or who did you ask is a better question. So the explanatory variable is you ask people, right? And what was the response? The response was their age. So we're looking at situations where there's a start, who did you ask, or what was the first piece of data you collect? And then the second one, the one that's called the response variable, is what was their answer. And it's very often the response variable that we're interested in. So it could be what was their answer, which is very common, or it was the second data point collected. So to give you an example, suppose I went around 12 shops in Bremerton and found out how much a dozen large eggs cost. Right? In that case, the explanatory variable with the shops that I visited, and the response was the cost, how much eggs cost me. You see, there's a where you got the information from and what the information was, right? Kind of makes sense that you'd have to have two steps to it. And this is the one that we tend to be kind of interested in. For me anyway, I find these questions quite difficult to do because the English language is quite subtle at times. And so I very often, if I'm careless, think the first thing they mention is going to be the explanatory, and then the next thing that comes after that is going to be the response. Mostly because most of the time it is, but then they catch me out by the way they phrase it. So when we look at this kind of situation, try and bear in mind that you have to be careful about who the first thing is and who the second thing is. And I'm hitting the wrong button. Let me try that again. Okay, so here's question 5. I think I should make this bigger. That might help everybody, including me. There. Each pair of variables specify which variable is the explanatory one and which is the response variable in the relationship between them, right? So there's only two choices. So you know if you've got 5 guesses, you're going to get it right. But we want to make sure that we're learning. So you make sure that you do it and you try and do it by not guessing. So the score on a final exam and the final course given. So the first thing is the explanatory, right? And the second thing is the response. So score in the final, explanatory, grade you got goes second. Right, that's it, guy. And oh, shooting space. Excuse me. Close that guy off. I want to do it as a student view. That way I can show, I can check it, basically. Here we go. Right, so it was question 5, wasn't it? Right, so score in the final exam, the final score in psychology, and I said it's that one. Now, the second question, the opinion about the death penalty, favour or oppose it, and the gender, male or female. Now, that one I'm going to switch places. You're a male or a female, and then they want to find out, are you in favour or against the death penalty? So in that case, the explanatory variable is going to be the sex, and your opinion on the death penalty is going to be the response. Right?
Professor, I think
yes.
A is backwards.
Did I go and do it wrong? Oh, sorry.
I think that's right.
Yes, yes, you're right. Which proves to you, you should read the question, because I thought I was hitting the dot when it said that. So, fingers crossed, go for it. Am I good or am I good? At least when I get help, right? Okay, let's see. We've done ordinal and that, and we've done continuous and that. So, feeling about importance of religion and the age of the respondent. So who are you asking here, I guess, and what is their answer? That's kind of where we're going. So I'm looking at this and I'm thinking it's going to be the age of the people and then how they feel about things. So the age of a person and their feeling about the importance of religion. Okay, so you see it's not clear. You have to kind of think it through. I try and think of what one is the first thing, but what more important is, what's the answer that I'd be interested in collecting? And here, the answer is I'm interested in collecting what their feelings about religion are. And then the top one is, you know, what kind of people am I asking? Okay. Now, here's one about smoking. I don't want to do them all. Here is one about IQs. I should do the IQ one then because it looks longer. To answer the following questions, researchers would measure 2 variables for each individual unit in the study. In each case, specify the 2 variables and the variable type for each, okay? Then specify which is explanatory and which is a response. So which one will I do? Is the average IQ of left-handed people higher than the average IQ of right-handed people? So the way I'm seeing that is that you're going to get a whole load of people and they're going to be right and left-handed people and you're going to check their IQs. So to me, left and right-handedness is who you're asking and the IQ score is what you're getting from them, right? The answer. So when I see it that way, the explanatory variable, right, is going to be whether they're left or right-handed. And I would just call that categorical. If there are only 2 things, I don't want to call it ordinal. The response variable is the IQ of the individual. And is the IQ, which one of those 3 is the IQ?
Quantitative?
Quantitative, right. Fingers crossed. Go for it. Am I good or am I good? Right? Now, one of the nice things about it is if one of those was wrong and the rest were right, at least it would only tell you the one that was wrong. And so you don't need to say, well, there are about 24 combinations here, right? And I don't know which bit I got wrong. You can see the married couples and pets and getting divorced. I don't know if I need to do another one of those. Do you want me to do one more of these or can we move on to the next thing, which actually does numbers? And I like numbers. you want to see one more, or are we good? We're good. Okay. So let me return to my whiteboard. That way I can kind of show you in my calculator all the stuff I'm doing. And we collected a table here. And although if you've never done WebAssign, you might be surprised to know that you all get, in many questions, unique questions. Same basic framework, but they changed the numbers. So if Lauren was having trouble with question 12, which is a version of the one I'm going to do right now, if you had a problem with question 12 and she phoned up Caitlin and said, I need some help on this, and I'm cool with people, I am, hopefully that person got it, right? I'm quite happy with that. But the problem is they won't be able to help you because they're going to say, but they're not the numbers I've got. Oh, that's pretty good. Can you see my transcript at the bottom, everyone, or just? No? Okay, that's fine. So
I see.
someone asked for me to do it, so I just said yes. So if you can see it, that's great. So what we've got here is wear seatbelts and frequency. So they asked in this story, this is my version of question 12, they asked 12 graders, who we all know are immortal and don't listen to anyone, how often they wore their seatbelts when they were in a car. And never, in my data, 100 of them. Rarely did it, whatever rarely means to them, 240. Sometimes did it, which according to my data is 281. Most of the time they did it. And that's 468. And last but not least, they always did it. And that's going to be 1,422. And they told me that the grand total, so it saves me having to add them all up, was 2,511 students. That's a lot of people, so it's good data. Before we go on to what they're asking you here, which is percentage of the times and things like that, where's a seatbelt, right? Would you agree that this particular is categorical and it's ordinal? It's got a natural order to it, right? That's not being asked, but we got that. What is being asked then? They're asking you for percentages of different groups. For instance, they might ask you, what percentage never wear a seatbelt? Well, you take the number that's never worn one, and you divide it by 2,511. And since the answer has to be a percentage, you multiply by 100. Does that seem obvious and reasonable? Right. So what percentage never took a seatbelt? It's 100 out of this. Right. Finally done that. So I just go to my calculator, and they want the answer rounded off to 2 decimal places. So here goes. 100, 2511 times 100. And the answer to 2 decimal places is 3.98%. That makes sense? Now, you could be asked what percentage rarely use it, what percentage always uses it, but won't it be basically just another version of this calculation? We cool with that? Or do you want me to do another one of these so you feel you know what's going on? Want to see another one? Okay. Let's suppose they went and said, what percentage of students sometimes wear seatbelts. Well, that is 281 students out of a grand total of 2,511, and then multiply it by 100. That's how it becomes a percent. And so I go here, and I go 281. I divide it by 2,511, and then I times it by 100, and I get the answer. 11.19 when I round it off to 2 decimal places. We good? Now, if you did that to every single one of these things, right? In other words, you've turned them into their percentages. So the never was 3.98%, right? And they always did it was what, 11.19%. And you can imagine I did it for the other three as well. What you could then create would be a visual, right, a picture to show the same kind of data. And when you do this picture, it's called a bar chart. Whenever you are dealing with categorical data, the picture that you tend to create is called a bar chart. It's a good name. It's made up of rectangular bars. And what you do is you put here, say never. And then next to it, you'll do rarely. Then I'll just call it some for sometimes, MT for most times, and I'll finish with always. And then your vertical scale, in this particular case, is going to be percentages. And you have some kind of scale. It might be 5, 10, 15, 20, 25, 30, 35, 40. Right? And I've only got a couple of the numbers. So the nevers was 3.98. So if you think about that as 5, 3.98 is probably about here. And the 11.12, the always is about roughly about here. And then can you imagine me doing a I'm not making any attempt to be accurate here, but imagine you would do rectangles for the others. And that would be a bar chart. And you would use the numbers that you got from these percentages to create how high each of these rectangles or bars would be. Make sense?
Mm-hmm.
Right. So what I'm going to hopefully show you in a few seconds from now is what's called the salt button. Darn it if I can find it now. Right. Okay. Now, sorry for being very distracted because, as I've told you before, I do not multitask well, and I was trying to do two things at once. Okay, so let's zoom over now and kind of show you a cool little trick. Some questions have this little button called the salt button. I'm going to have to shrink this up a little. If I can do it, is it up here? Yeah. Hopefully you can still see the gist of what's going on here. Right, here's our question, right? Now, if you, oh, darn it. The numbers have been changed because I went up and changed something. But can you imagine it's the same question I had a few moments ago, right? So what you do is you hit this salt button. And you can see the same data that we had, right? The stuff here. And now you can go and you can click on various things. For instance, if I click on charts and graphs, and then I click on wearing seatbelts, and then I do relative frequency. And you might think, what is relative frequency? When you do a bar chart and the vertical line is percentages or decimals like 0.1, 0.2, that kind of thing, well, we tend to call those relative frequency. And if you use the raw data, like 100 people said this and 200 said that, then it's just called the top one, right? So when I recalculate this, we see our little histogram, or I should say our bar chart. And can you see the shape of it? And it's a bit like a ladder, isn't it? Or stairs climbing upwards, right? That's for it's going up, 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 which is good news because you would hopefully figure out that most people think wearing a seatbelt is a good thing to do, right? And so the more often you do it, seems to be most common. Now, if you wanted to, for instance, click on, let's say this one here, not that one, definitely not that one, maybe this one, yeah. No, I got it. I think I've missed it. I probably have, okay. Yeah. I thought it would be here, but evidently I'm wrong. Okay. Well, at least you got the bar chart. In other situations, you'll be able to do more things. Now, on the one that we've got, even although I only had it for a few seconds, would you agree it had that shape? So that's what you could do. You could do it yourself by the original data. Couldn't you just go and draw something that looks like it and say, yeah, it's basically that shape? Now let's look at this next question. What we have here is a survey of participants. We're asked, would you say that you are a happy person, pretty happy, or not too happy? Okay. And the results were 681 said that they were very happy. So I'm just filling in the table, 631. And then pretty happy, well, that dropped down, didn't drop down, it actually increased to 1,387. And then not too happy was 356. Now, do you see that they want you now to calculate relative frequency in percents? So if I wanted to do just this one, although I won't do the calculation because I'd have to come in and out and that, it wouldn't be oops, wrong button. 631 divided by, okay. What number will I have to divide it by? You don't need to tell me what the number is, but tell me what I would need to do to get that number.
Your number for people who are very happy is incorrect. It's 381, not 31. Or 681.
Good grief. Oh, I just hit the wrong button. There we go. Okay, now back to my first question then. What is the bottom number going to be? Or at least how will I get it?
The total number of people.
Yeah. Total number. As we're waiting, I'm trying to hit this on my calculator. And got a number back to front. And I get 2424. So let's say it's 2424. And then wouldn't you multiply that by 100? Right. So that would be the calculation. Agreed? 681, those are happy. Divided by the total number of people in this survey, it's 2424 times 100. So since I have my calculator right in front of me, 681 divided by 2424, and the answer is 28.09 to 2 decimal places. So 28.09, and let's go for it. Oh, am I good or am I good? After you fixed it for me, right? Are you comfortable with what you need to do in this kind of question, right? Now, once you're finished, won't you have 3 answers, right? That guy and these 2. And then you go down here and you look at the possible choices. And if I hit the salt button, I could certainly look at the answer and then zoom out and say which is it. But I think I can have a good guess. Not a guess. Since this is 28.9, would you agree the only one that has very happy that looks like it's probably at 28.9 is this one? So I don't really need to pay much attention to the others once I've figured that out. If there were 2 of them at the same place, then wouldn't I probably then look at the pretty happy to see which one was that number? And I guess if they were really sneaky, I might in some questions have to look at the last one as well before I could finally separate them and say, yeah, that one works and that one doesn't. A little trick. If you do these 3 guys, what should they add up to if you did it right? Yes, I saw somebody going like that. Shouldn't they add up to 100%?
Yes, they should. Question for you.
Yeah.
If I can. When you first punched it into the relative frequency, you punched it in as the
Calculation.
thank you, as the calculation. Yeah. Can you do that there and will it automatically convert?
No, it won't typically do that. I just did that to show you what I was typing, so I didn't go out in it. You have to put typically the answer in. Word of advice here, it should add up to 100, but sometimes it adds up to 99.98, and sometimes it adds up to 100.01, and it's not that you're wrong. How could that happen? Or why did that happen?
Rounding.
Rounding. You know, sometimes you round up and then you take another answer and you round it up. So you end up with an answer just a little bit bigger because of that. So that's okay, right? But if you add the 3 up and it's 108%, you're wrong, right? And if you add the 3 up and it's 82%, you're wrong. But if you add them up and it's 100.1%, I'd be pretty comfortable that I was okay. It doesn't matter in homework because won't WebAssign tell you you're wrong? But you know, if you're doing a test question, you don't get told if you're right or wrong. So wouldn't it be good if you had just a little quick check? Yeah, that number seems to fit well. I'm happy. I'll move on. Oh no, that isn't even near what it should be. I must have screwed up in one of my calculations. I'll have a quick check to see which one it is. So it's, if you can do things like that, it's sometimes helpful. Okay, let's do 14 as our next one. Oh God, time shoots by when you're enjoying yourself. In a survey done in 2010, students in a stats class were asked, how do you prefer to use your cell phone, to talk or to text? Of the 107 self-identified women, so that is the data that's going to go here and here, right? So of the 107 of them identified, 23 said they like to use it to talk. And 84 said they like to do it mostly to text. And yep, that does add up to 107. So that's good. And then they asked men the same question. And when they asked self-identified males, 87 of them said they like to talk. No, it isn't. 87 is a total. 33 said they like to talk. 54 said they like us to text. And that added up to 87. So what we've essentially got here are 2 samples. Men were asked it, women were asked it. And one of the things you might be interested in finding out, I think I would be interested in finding out, is there any difference between men and women in this particular situation, right? Do they talk and text about the same? You can't use what's called the raw data. You can't say, this is bigger than that, so that means women like to text more than men. And you can't say normally this is less than that, and that guarantees that women, right, do more or less than the other. And the reason you can't do that is, aren't these samples different sizes? Can you imagine you asked 5,000 women, but only 50 men? Wouldn't the women numbers always be bigger than the men? But if you want to say how to compare them, don't you really need to do percentages? So what I'm going to do is I'm going to take these guys and we're going to make them into percentages. So the first one is 23 out of 107. So if you can hang in here and tell me if I screw up, that would be great. If we do the first one, it's about, I'm going to just make my life easy and I'm going to round it off to the nearest whole number, right? So 21%. And the other guys then, I don't really need to worry about that. If one of them's 21, won't the other be probably what's left? That makes sense? Now, what about the men? 33 out of 87. That ends up being 38%. And that means that in this, oops, I guess I should put my percentage in, be consistent. And then over here, I'm going to put 54%. Is that right? No. 62%. The total in both cases would be 100% or darn close to it, bearing in mind that sometimes you get rounding off errors. Okay. Now I should be able to do some reasonable predictions. Looking at this table, would you say that there's evidence that women tend to text more than men? And obviously the converse is true. Women talk less on the phone than men, at least in this data set. Now, do you see how turning the data into percentages, relative frequencies, another name they sometimes use in that context, is much more helpful in looking at the data in a different way? That's what it's trying to give me evidence for. I'm not saying that this is guaranteed, because, you know, if you only ask a couple of hundred people, couldn't anything be true? I'd be much more comfortable if they'd done like 100,000 people, you know, a really big sample, because then it's less likely that you just get unusual data. Does that make sense? Is there anything up to what we've done right now that you want me to go over before we finish off? And while you're thinking about it, will you say hi for attendance?